All right, hey y'all. So today we're going to talk about solutions chemistry. So before we start off, I just want y'all to know that I'm going to abbreviate solution to SOLN all the time because I don't want to write a lot of things. And when we talk about solutions, generally people think about mixing things in water or pouring two liquids together like liquid mixtures. But really, it can just be any mixture. And we're going to first start off by defining a whole bunch of terms. So I'm going to do that as quickly as possible. So first off, we have homogeneous versus heterogeneous. And homogeneous is anything that mixes and can't be separated by physical means. Um, and what I mean is like you can't just go in there and scoop out whatever you've mixed in. So an example might be like salt and water. If you go ahead and mix salt and water and you let it all dissolve, you cannot physically go ahead and just pick out salt crystals. So salt and water, maybe alcohol and water, anything that mixes kind of like that, versus heterogeneous, which is things that don't really mix. An example might be like a marble in water. If you take a marble and you put it in water, you can just pull it right out. Maybe even marbles and sand. If you take a bunch of marbles and you put them in sand, you can kind of just scoop them out, and that would be something that's heterogeneous. The next ones we're going to define is solvent and solute. Solvent is the thing that does the dissolving. So when you put something in a solution and it dissolves, the solution that you put it in that dissolves it, that's your solvent. Your solute is the thing that dissolves. So we're going to go back to our heterogeneous mixture idea of some water. I'm going to go ahead and just fill this with water. And then I'm going to put some salt in there. So we have salt and we have water. Now, water is going to be our solvent and salt is going to be our solute. So whatever does the dissolving will be our solvent. Whatever is dissolved is our solute. And just a quick appendix, when we say something is aqueous, we sometimes use AQ. We just mean that it's dissolved in water. So that's a quick important definition to know. If something is aqueous, like sodium chloride AQ, we just mean we have salt and water. So we might actually define this whole thing right here as NaCl aqueous. All right, the next thing we have is concentrated versus dilute. Concentrated means we have a lot of solvent, or sorry, not solvent, my bad. We have a lot of solute in our solvent. Dilute is we have very little solvent. Or I just cannot get this one right. We have very little solute in our solvent. So we can just really quickly look at this in an example. So I'm going to make 2 beakers of water. So concentrated would look like this. Just putting a whole bunch of solute. Oh, I should actually go even less hard on the dilute. Well, dilute kind of looks like this. Generally, a good example I like to use is if you're making like high C, when you pour a little bit of water and it's very flavorful, that's concentrated. When you add more water, as you add more water, it dilutes it, and that becomes dilute. The next two terms, soluble versus insoluble. Soluble means the solute dissolves in the solvent. Insoluble means the solute doesn't dissolve in the solvent. And that's a pretty basic definition. Salt dissolves in water, but oil doesn't dissolve in water. So we can think about the soluble as like salt plus water, insoluble as oil plus water. Gonna make that a little neater. All right. Coming up on our last two terms, saturated versus unsaturated. Again, you can already notice all these terms are just kind of inverses of each other. Saturated is the max amount of solute in a solvent. Unsaturated is anything that is not the max amount of solute in a solvent. And basically, if you make your solution of water and you pour salt in and you keep dissolving it until it doesn't dissolve anymore, that's saturated. The last thing is, I'm just going to add right here, we can do something called supersaturated, which exactly like it sounds, it's more than the max. And I'm actually going to make my job a little easier. More than the max amount of solute in a solvent. And you can do that in two ways. You can achieve this with either heat. You can change the temperature, and by heating up a solution, you can add more solute, or pressure. By adding more pressure to a system, you can add more solute, but this kind of generally works with gases. And you actually see this every day with a soda. When you open a soda and it goes, that is actually the sound of the gas escaping because pressure had supersaturated that solution with gas. All right, this next thing, and this is like the most important thing, is molarity. Molarity is also known as concentration. So you might say the concentration of something in a solution, and we actually use a capital M to denote molarity. And what it actually means is the amount of moles of solute divided by the liters of solution. So that's not liters of solvent, that's liters of the whole solution. So when you make a whole solution, the amount of liters under the total number of moles, we generally just have an equation for it. M equals mole over L. So molarity is equal to the moles divided by the liters. And the units for molarity are actually moles over liters. And this becomes really important because now we're going to start doing some math about it. And this basically tells us how concentrated a solution is. So molarity tells us how much solute is in a solution. All right, so our first question, if we have 4 moles of sodium chloride in a solution which has a volume of 2 liters, what is the molarity? I think the best way to do any of these problems is just write M, mole, and liter, and just see which ones you have the values for. So right here, I see I have 4 moles and I have 2 liters. So I'll go ahead and put 4 mole, and I'll also put 2 liter. And I see that I'm solving for M. So I can just do M equals mole over liter, which I can then substitute in for 4 over 2 mole over liter. And I can do that division, and so our M is equal to 2. And the way I would write this in final is we have a 2 molar solution of NaCl. Whoops, that is not a capital. And there's my answer. So we're going to try this again with one more sample problem, and then we're going to call it. So before I even read the question, I'm going to write M, mole, and liter, because that's what I want you to focus on. And as we read, we'll highlight. If we have 2.5 liters of a 6 molar solution of magnesium chloride, how many moles of magnesium chloride do we have? So we're actually looking for moles. So we can do that because we're just going to fill this in. 2.5 for liters, 6 molar for molarity, and we're looking for moles. So I'm going to go ahead and write M equals mole over liter. And I'm going to fill that in with what I know. I know I have 6 molar equals some unknown amount of mole over 2.5 liters. The best way that I can think about doing this is we'll multiply 2.5 over 2.5 liters. And this is just algebra now. Oh, sorry, my bad. I actually did this wrong. We'll just multiply by 2.5 on both sides. 2.5 liters cancels 2.5 liters. And then we get 2.5 liters times 6 molar is going to be equal to some number of moles. And this math just tells us that we have 15 liters times molarity equals some number of moles. And well, it turns out if mole is just mole over liter, liter times mole over liter, and liter will cancel out. This is just equal to 15 moles. And then we'll throw in our MgCl2 just for good measure. So it turns out that we don't even have to use the equation in the way that we assume. All we have to do is fill in 2 out of the 3 variables, and we can find the third one, which is usually what your question is asking. And I apologize, there's one more question. So we're going to do this one super quick. I'll fill out mole, molarity, and liter. And we'll just fill these in as we read. If I want to use 7 moles of solute to create a 5.5 molar solution, how much solution will I make? Well, we can fill this in. We have 5.5 molar. We have 7 mole, and a big fat question mark for liters. So we'll just fill this in as molarity equals mole over liter. 5.5 molar equals 7 moles over some unknown liters. The really fun thing about algebra is that we can take some shortcuts. Right here, we can just swap these two. The real thing is we'll divide liter on both sides and then flip and do some inverse, but the best way is just swap those two. And so our liters is equal to 7 moles over 5.5 molar. And so we can just calculate this out as 7 divided by 5.5. And turns out we get the answer of 1.27, repeating mole over molarity, which that actually just cancels out to liters. So we will make a 1.27 liter solution. And that's that. If you want any more practice problems, please go ahead and do the homework I assigned as many times as possible. And have a great night.